Hello and welcome back. We're going to continue our unit on reasoning and proof as we begin to look at what is known as deductive reasoning. Deductive reasoning builds off of inductive reasoning that we looked at in our first lesson. Inductive reasoning was based off of observation and making conjectures based off of that. Here, deductive reasoning is more logical. Okay, we are taking a look at what we have and using rules and laws and properties and making decisions based logically that way. Okay, so as you can see, the penguin does not have very good deductive reasoning. Penguins are black and white. Some old TV shows are black and white. Therefore, some penguins are old TV shows. So, penguins aren't very good at logic thinking, but you are. So let's continue and practice our deductive reasoning. Okay, two laws of reasoning that we have, the laws of logic. One is known as the law of detachment. Okay, that's where we have a conditional statement. We'll look at some examples in just a moment. But if the hypothesis of the conditional is true, then the conditional statement is also true. Okay, so that's what we refer to as the law of detachment. Okay, the hypothesis is true, conditional is also true. Okay, you can think of it as, they were detached, and now they're both true. Law of syllogism, that's a funny word. Not even sure what it means, but now you're going to Google it and look it up and let me know in class tomorrow. But that's where one thing leads to another. So if hypothesis P, then conclusion Q. And if Q, then R. And if both those are true, so if this leads to another thing that's true, and that leads to another thing that's true, then we can just skip that middle step and just say, if the first thing happens, then the last thing has to happen. Okay? So let's work through a couple examples using law of detachment and law of syllogism. Okay? The law of detachment is, remember, if hypothesis is true, then conclusion is true. Okay? So let's see if we can make a valid conclusion here. If two segments have the same length, then they are congruent. Okay? So now we have a detached statement, something that's different, but it follows the same format. So you know that BC equals XY. Okay? Well, let's take a look at that original statement. If two segments have the same length, then they are congruent. That is a true statement. Okay? So now we know BC is equal to XY. Well, if BC equals XY, they have the same length. Therefore, we could conclude that BC is congruent to XY. Okay? So, next one. If Mary goes to the movies every Friday and Saturday night. Today is Friday. Okay? So this is our original statement. Okay? If we want to write that in an if-then statement, we'd say, if it is a Friday or Saturday night, then Mary goes to the movies. Okay? So if today is Friday, what can you conclude? Well, we can conclude that she's at the movies. Okay? So, once again, we take a statement, put it in if-then form, if that's a true statement, a true conditional statement. Then if we have a detached statement, a new statement, we can apply it to the rule and see if it works. Okay? Now the law of syllogism. Okay? That's one that one event leads to another, which leads to another. Okay? So if Rick takes chemistry this year, okay, then Jesse will be Rick's lab partner. If Jesse is Rick's lab partner, then Rick will get an A in chemistry. So what can we conclude? Okay, so we'll say if P, then Q. So if Rick takes chemistry, Jesse's going to be his lab partner. And notice we repeat this one. If Jesse's Rick's lab partner, then if Q, then R, then Rick will get an A in chemistry. Okay, so it's kind of like that children's book. I don't know if you've ever read that before. If you give a mouse a muffin, or I forget. I'll have to go find it. Anyway, we can finally conclude that if Rick takes chemistry this year, we know Jesse's going to be his lab partner, but he's going to get an A in chemistry, is a conclusion that we can make. Okay? All right, we'll get to the next example, but before I forget, I figured out the book I was trying to remember. If you give a mouse a cookie, okay? Not sure if you've ever read that one. Read that one to my kids a lot, but it's basically conditional statements. If you give a mouse a cookie, then he's going to ask for a glass of milk. If you give him the milk, then he'll ask for a straw. And that continues the whole way through. And so basically the moral of the story is, if you give a mouse a cookie, well, the law of syllogism applies. Well, he's going to be thirsty. He's going to want a glass of milk. And then he's going to want a cookie that goes with that. So it just repeats the whole way through, just one conditional statement after the other. Kind of like the law of syllogism. We could just conclude that if you would have given that mouse a cookie, he's going to want some milk because he's going to be thirsty. A whole bunch of them in there. If you give a pig a party, I think there's another one. If you give a moose a muffin, but anyway, we're not reading those right now. It's not story time. Okay, B. If x squared is greater than 25, then x squared is greater than 20. If x is greater than 5, then x squared is greater than 25. Okay, so here we need to find out which one we can conclude there. Okay, so if we take a look there, notice the conclusion of that second statement is the hypotenuse, or not hypotenuse, hypothesis of the first one. So these are the same. Okay, so law of syllogism, we're looking for one thing that leads to another. So this is our first statement, and how we defined it before, this would be if P, then Q. If Q, that's the one that repeats, then R. So we can conclude if x is greater than 5, then x squared is greater than 20, as we have listed down here. Okay, we can just skip that step in between because it's going to lead to that final step anyway. Okay, so the law of syllogism allows us to simplify things a little bit. Finally, example C, if a polygon is regular, then all the angles in the interior are congruent. If a polygon is regular, then all the sides are congruent. Okay, so can we make a conclusion if the polygon is regular? So what's the same thing that's repeated? Here we have if a polygon is regular, if a polygon is regular. Those are both the hypotheses. Okay, so it doesn't lead to another. We just have a hypothesis that says if it's regular, well, then the angles are going to be congruent and the sides are going to be congruent. So we can't apply the law of syllogism there. We don't have a shared conclusion and hypothesis that leads to the next. It's just two basically parallel statements. Okay, so basically what I said there. Now, let's just practice determining whether we're using law of detachment or syllogism and what conclusions we can make. So looking at the example here, if 90 degrees is less than measure of angle R, which is less than 180 degrees, then R is obtuse. Well, the measure of R is 155, so what statement can we make? Well, it's got to be obtuse. Okay, because that is, matching the qualifications that were listed in here. Next one, if Janelle gets a job, she can afford a car. If Janelle can afford a car, then she'll drive to school. Using law of syllogism, what statement can you make? Well, do we have any connecting statements? If Janelle gets a job, then she can afford a car. If she can afford a car, then she's going to drive to school. So yeah, the conclusion of this statement is the hypothesis of this one. So we can just ignore that whole step there and just say if she gets a job, then she's going to drive to school. Okay. 3, if you get an A or better on your math test, then you can go to the movies. If you go to the movies, then you can watch your favorite actor. My conclusion is if you get an A or better on your math test, then you can watch your favorite actor. That is the law of syllogism. And number 4, if x is greater than 12, then x plus 9 is greater than 20. The value I have for x is 14. Therefore, I can conclude x plus 9 is greater than 20. Which law is that one using? Law of detachment. Very good. Nice answer. All right. Moving along. In geometry, we're going to be using our inductive reasoning to make a conjecture. We also then need to use our deductive reasoning to show that our conjecture is true or false. So we need to know which type we're using in order to know, well, do I need to make a conjecture here or do I need to prove something by using logic? So what conclusion can we make about the product of an even integer and any other integer? So say, for instance, I take 2 times, let's say, 6. Well, 2 times 6 is 12. Okay, let's try another one. 4 is an even integer, and 7. 4 times 7 is 28. Okay, so based off of what I'm seeing here, let's try another one. 4 times 8 is 32. I'm going to guess that I get an even product. Okay, so that's my conjecture. Okay, tried a couple examples. Here we've got a few more examples. They tried negatives in there. Those are even. Yeah, we get even numbers every time with each of the examples that are tried. Okay, so once we've used our inductive reasoning and made a conjecture, we need to test it. So let's use our deductive reasoning. Okay, so in order to use our deductive reasoning, we'll use a little bit of number sense. So let's call some variables. Let's use some algebra now. So n and m are our integers, and we'll show that this is true. So 2n is an even integer because any integer multiplied by 2 is even. So m is the other integer because it can be anything. So 2 times n times m is that product of the even integer and any other integer m. So 2nm has to be an even integer because if you multiply 2 by anything, you get an even number. Okay, so that's using rules that we've learned before. You've learned that anytime you multiply by 2, you get an even number. And we know that when we multiply, it doesn't matter the order. So I could multiply these two numbers first, and then by 2 it's got to be even. So that proves it using our deductive reasoning. Okay. So now let's finish up by just determining when we're using inductive reasoning, when we're using deductive reasoning. Okay, so decide whether it's inductive or deductive. Why don't you read those examples, pause it, and determine whether it's inductive or deductive reasoning. Okay, so the first example. Okay, Monica's kicking the ball up in the air and she figures out, hey, the ball comes back down every time. She is pretty smart. Okay, she's also not on the moon. So she's kicking the ball up and she's observing that it comes back down to the ground. So since it's using observation, it's using her inductive reasoning skills. Okay. Letter B, reptiles are cold-blooded. That thing right there is not cold-blooded. Okay, so she comes to the bright conclusion that my pet parrot is not a reptile. Wow, she is using her deductive reasoning skills. Okay, and most specifically, she's using the law of detachment because this is my rule. Reptiles are cold-blooded. Okay, my parrot is not cold-blooded. Well, therefore, it's not a reptile. Okay. All right, that's all the time we have then for today. We've learned how to use our deductive reasoning skills and focused on the law of detachment and the law of syllogism. Okay, and you're going to look up what syllogism means and get back to me. We also have a reading assignment. You need to find this book and read it. That's all we have. We'll see you later.
If you give a mouse a cookie, he's going to ask for a glass of milk. When you give him the milk, he'll probably ask you for a straw. When he's finished, he'll ask for a napkin. Then he'll want to look in the mirror to make sure he doesn't have a milk mustache. When he looks in the mirror, he might notice his hair needs a trim, so he'll probably ask for a pair of scissors. When he's finished giving himself a trim, he'll want a broom to sweep up. He'll start sweeping. He might get carried away and sweep every room in the house. He may even end up washing the floors as well. When he's done, he'll probably want to take a nap. You'll have to fix up a little box for him with a blanket and a pillow. He'll crawl in, make himself comfortable, and fluff the pillow a few times. He'll probably ask you to read him a story. So you'll read him a story from one of your books, and he'll ask to see the pictures. When he looks at the pictures, he'll get so excited he'll want to draw one of his own. He'll ask for some paper and crayons. He'll draw a picture. When the picture is finished, he'll want to sign his name with a pen. Then he'll want to hang the picture on your refrigerator, which means he'll need Scotch tape. He'll hang up his drawing and stand back and look at it. Looking at the refrigerator will remind him that he's thirsty. So he'll ask for a glass of milk. And chances are, if he asks for a glass of milk, he's going to want a cookie to go with it.